Okay, now let's look at another question. This is a velocity function. Okay, is a fixed point t second after passing the. If t is equal to 0, then the particles is at point O. Okay, now let's answer the first question. Explain why the particle is never at rest. If you at rest, v equal to 0, so you put v equal to 0 and make t the subject. Okay, now and you get half beyond bracket minus 3 over 2, but this value beyond minus 3 over 2 or minus 1.5 doesn't exist. There's no such thing as like for example log or even beyond negative beyond of a negative value. So from here this doesn't exist, therefore t cannot be found when v equal to 0. Therefore we can say that b cannot be equal to 0. Now the second one, which is r equal to the acceleration 12 meter per second square. Now this is a velocity, so what you have to do, if you differentiate, then you get the acceleration function. So you differentiate dv dt. Okay, now you got 8 e2t. Now if you substitute dv dt, which is acceleration 12 inside, become 12 equal to 8 e2t. Okay, simplify it further is bring the 8 over here, become the denominator, so it's 3 over 2 e2t. Now simplify it further, come over here, beyond on both sides, so it's log 3 over 2 beyond e2t. Okay, so what you have is from here beyond 3 over 2 become 2t, so this will lead to t equal to half beyond 3 over 2. Okay, now what you do, you use the calculator to find this value. Now this is a very simple one. Now whatever we're going to do next is regarding this question here. Okay, this question. Now let's go back to the function v equal to 4e 2t plus 6. Okay, now let's sketch this. Okay, let's sketch it over here. Okay, now t is v, t is t. Now when t equal to 0, equals 4 e, t equal to 0, so e to the power 0 is 1, so 4 plus 6 become 10. So basically when t equal to 0 is 10, is 0. Now and the other point we want to look at is what is the minimum value of v. Okay, you see this value here the minimum is 6 because this value can never become negative. Okay, but then it cannot be 6y because no matter how there is still some residue value. If I put t equal to negative, this term a very small value, very big negative t, then this become a big value. Okay, in other words, if you take the negative t, there is an asymptote here at the point of 6. Okay, let me say if I sketch this curve, it will be like that. But you never, the y will never touches 6. Okay, minimum, because this is, there's some, no matter t, you put a negative t, a big negative t, it become a reciprocal. Okay, but there's still some value. That means v can never become 6, but very close to 6. So v equal to 6 is actually the asymptote. So this is 6. Okay, now this v, this t, if you integrate, if you can find the area below the curve, like integration, okay, velocity versus time, the area under the curve will be actually equal to the distance. Like what we learned in modern maths, if you want to find the distance traveled, if velocity is the y-axis, t is the time, and if you find the area under the curve, that will give you the distance. Okay, so if you can integrate this, putting the definite, that means the maximum and minimum value, then you will get the distance. Okay, from this time. So we're saying that from t equal to 0 to 4, let's say from here is 0.4. Okay, then from here 0.5. Okay, so if you integrate this now, let's integrate this. Integrate v 0.5 0.4 dt. Okay, this will give us the area under the curve. With the y-axis as the velocity and the x-axis as time, the area under the curve is actually the distance. Okay, now this one thing that I want to highlight here is there a turning point at this point here? Okay, does the velocity change in direction? Okay, this is very key. Okay, as we seen in the earlier example, the particle actually make a turn in the opposite direction. So for that kind of cases, you cannot just simply put the t, the definite integral inside, because when you go in opposite direction, then the distance gain is negative. Okay, so this question say that what is the distance traveled by r? So as long as there's no turning point, then you should substitute the t1 and t2, then whatever value you get will be actually the answer. Okay, no concern over it. So in this case, you integrate this, what finally you get is 8 okay, sorry, no, this, when you integrate this become 2 e. Okay, now if you integrate the v function, this is what you get. Okay, then you substitute inside, you get the distance traveled by the particles during the interval t equal to 0.4 to 3 equal to 0.5. It's a very straightforward answer, as long as there is no turning point in between the period. So is we will continue this in the next video.